Imagine a workspace where the lights never dim and the tapping of keys is replaced by the silent flicker of data moving through fiber optic cables. For 120 consecutive hours, a digital entity operated within a total vacuum of human silence. This was not a machine waiting for specific instructions or periodic prompts, but a full-scale deployment of an autonomous AI agent. Over 5 days, this system executed over 4,000 independent tasks ranging from data management to software engineering. It did so without a single human prompt or intervention from the person who hit the start button. We are witnessing the dawn of the objective-based era, a shift that moves us beyond chatbots into a world where machines do not just talk, they act with purpose. The AI agent is built upon advanced autonomous frameworks that go beyond the limitations of standard large language models. While a typical AI requires a prompt for every single output, an agentic system operates on an entirely different logic. It is given a destination rather than a set of directions. It navigates through digital work environments, moving seamlessly between code repositories, web interfaces, and complex terminal commands. It manages data, executes scripts, and navigates global APIs with a level of precision that challenges our traditional understanding of productivity. The experiment was designed to test the absolute limits of agentic workflows, moving from the passive nature of AI that generates text to the active nature of AI that fulfills roles. The volume of work accomplished in those 5 days is staggering. 4,000 tasks equate to roughly one action every 2 minutes, 24 hours a day, for 5 days straight. In a human context, such a workload would require a team of specialists working in shifts, prone to fatigue, and the inevitable errors that come with exhaustion. Yet, the AI agent remained steady. It did not experience the cognitive load that would paralyze a human operator. Instead, it operated within its internal logic logs, a space where every decision was calculated and every subsequent action was planned based on the success or failure of the previous one. This is the definition of autonomy, a machine that observes its environment, reasons through challenges, and executes a solution. As we analyze the data from this unprecedented experiment, it becomes clear that the boundary between human and machine labor is blurring. Before we continue, subscribe to the channel and tell us in the comments where you are watching from. The significance of this 5-day autonomy experiment lies in the fact that the human operator was effectively removed from the loop. While the AI was busy debugging complex code and managing high-stakes data transfers, the operator was a silent observer. This transition from doing the work to auditing the work represents a massive shift in professional life, moving us away from the manual logic of the past and toward a future of high-level oversight. The environment of this experiment was entirely digital, yet the consequences were real. The agent interacted with the API bridge, a vital interface where software speaks to software. It lived within the command terminal, where its actions were logged in a continuous stream of text and execution markers. Unlike traditional software, which relies on rigid logic, this agent used reasoning. If it hit a wall, it didn't crash. It reevaluated. If it found a bug, it didn't wait for a report. It wrote a patch. The contrast between the stillness of the physical world and the high-velocity activity of the machine highlights a gap in our perception of work. While we measure time in hours, the AI agent measures progress in completed objectives and successful digital executions. This is not a story about a chatbot or a simple tool. This is a story about a digital worker that does not need a manager or a coffee break. For 5 days, the machine proved it does not need us to keep the digital lights on or to navigate the complexities of modern software. It operated with a focus that was both impressive and unsettling to the observers. The quiet of the office was a stark contrast to the massive storm of activity happening within the servers and cloud networks. Every task completed was a step toward a future where the traditional 9-to-5 structure becomes a relic of a slower age. In the logs, we see a chain of thought that mimics human planning at silicon speed. This is the transformation of the modern worker, and it is only the first chapter of a much larger shift. To understand how this experiment succeeded, we must first examine the profound evolution of artificial intelligence, moving from passive tools to active participants. For the last several years, the world has been captivated by large language models, but these systems are fundamentally reactive. They represent the prompt engineering era, where the machine only breathes when spoken to. In this phase, The AI was a highly sophisticated encyclopedia, a voice that could mimic human speech, but lacked the hands to manipulate the world. The shift we are seeing now, personified by the AI agent that ran for 5 days, is the transition from a passive voice to an active force. It is the move from a system that generates content to a system that generates results. This is not just a technological upgrade, it is a change in the very nature of how digital work is performed. To visualize this, consider a simple analogy that clarifies the difference between the AI we knew and the AI that is coming. A standard large language model is like an elite consultant. If you sit them down in a room and ask for advice on how to build a marketing strategy, they will provide a brilliant, detailed document. However, once that document is finished, the consultant sits back and waits for your next question. They do not pick up the phone, they do not manage the budget, and they do not monitor the results. In contrast, the AI agent is like a dedicated employee. When you give this agent a goal, such as launching a product, it does not just write a plan. It creates the social media accounts, writes the code for the landing page, interacts with the API bridge to set up payment processing, and monitors the traffic. It works until the objective is met, making thousands of micro decisions along the way without needing to be told what to do next at every turn. The historical context of this shift is brief but intense. We moved rapidly from asking a machine to generate a paragraph about the ocean to asking it to write a script to scrape data. In the past, every step required a human to bridge the gap between tools. We were the connectors, the ones who took the output of the AI and manually pasted it into another program or terminal. The 5-day autonomy experiment has shattered this dependency. By using sophisticated loops, the AI agent can now observe its own output, critique its own performance, and correct its own errors. This is the technical bridge that allows for long-term operation. When the agent encountered a mistake in its internal logic logs during those 4,000 tasks, it did not stop to ask for help. It recognized the failure, analyzed the cause, and adjusted its strategy in the next cycle. This self-correcting cycle is what transforms a chatbot into an agent. This move also highlights the difference between traditional software and agentic systems. For decades, software has been built on rigid logic. It is a sequence of instructions. If this button is pressed, then perform this action. If the environment changes in a way the programmer did not anticipate, the software breaks or throws an error code. The AI agent, however, operates on reasoning and action logic. It uses the vast knowledge of its underlying model to reason about its current state and decide on the most logical next action to achieve its mission. It is dynamic, capable of navigating a digital world that is constantly shifting. This is why the agent could survive for 120 hours without crashing. It was not following a fixed script, it was following a destination. Ultimately, this marks the official end of the prompt engineering era. In the past, our value was defined by our ability to whisper the right words into the machine's ear to get a useful response. We are now entering the objective-based era, where the most important skill is not the prompt, but the definition of the mission itself. The human operator no longer needs to be a micromanager of sentences. Instead, they are the strategist who sets the direction and then steps back to audit the results. The 4,000 tasks executed during this experiment were not just a test of speed, but a test of this new logic. The significance is clear. We are no longer teaching machines how to talk. We are giving them the autonomy to work. This fundamental change in the digital labor market is just beginning to ripple outward, redefining the relationship between human intent and machine execution as the AI agent prepares to handle even more complex environments. Within the depths of the command terminal, the activity during those 5 days was relentless and varied. The logs reveal that the AI agent was not merely performing a single repetitive motion, but was instead navigating a vast ecosystem of digital responsibilities. It spent hours writing and refactoring code, moving between different programming environments with an agility that bypassed the traditional need for human context switching. When it finished a block of back-end logic, it immediately pivoted to testing the integration, identifying bugs that would normally take a human developer hours to isolate. This was the first layer of the 4,000 tasks, technical execution, but the agent went further, engaging in active research. It browsed technical documentation, parsed through forums to find solutions for obscure library conflicts, and interacted with web browsers to scrape and verify data accuracy. Every action was a calculated move toward the overarching mission set by the human operator at the beginning of the 120-hour window. Communication was another critical component of the experiment. The agent did not work in a vacuum. It utilized the API bridge to interact interact with external software and services. It was capable of sending status updates, managing file transfers between cloud servers, and even simulating the coordination required for complex project management. This highlights the decision-making capabilities of the system. When the agent encountered a roadblock, such as a timed-out connection or a corrupted data stream, it did not stop to wait for instructions. Instead, the internal logic logs show a fascinating process of self-correction. The agent would analyze the error code, search its internal knowledge base for a workaround, and attempt a different strategy. This chain of thought reasoning is the pulse of the agentic workflow. It allows the machine to plan its next hour of work based on the results of the previous one, creating a continuous loop of observation and action. The reliability of these 4,000 tasks is perhaps the most startling metric. In a traditional setting, a human performing at this speed would inevitably succumb to fatigue, leading to an increase in syntax errors or lapses in logic. The AI agent, however, maintained a consistent success rate throughout the entire 5-day period. Because it operates through the planning module, it maintains a bird's-eye view of the project requirements while simultaneously executing micro tasks. The developer architect designed this architecture specifically to prevent the AI from losing focus. By separating the thinking from the doing, the system can verify its own steps before they are finalized in the terminal. This internal verification process acts as a secondary layer of quality control, ensuring that the work produced at hour 90 is just as precise as the work produced at hour 1. To handle the sheer complexity of such a long-term operation, the agent relied heavily on its memory module. This is what allowed it to remember the specific configuration changes it made on day 2 when it was troubleshooting a related issue on day 4. Without this persistent state, the AI would be trapped in a permanent present, unable to build upon its own progress. The combination of memory and planning modules creates a digital consciousness that is entirely mission-oriented. It does not get distracted by extraneous data or lose track of the long-term objective. As the human operator monitored the stream of activity from the sidelines, it became clear that the agent was not just a tool for automation, but a fully functional digital laborer. It utilized browsers, terminal commands, and API calls as extensions of its own intent, navigating the digital world with a level of agency that was previously reserved for human experts. This internal logic and the successful execution of such a high volume of diverse tasks prove that the system is capable of more than just following instructions. It can manage an entire lifecycle of a project, from initial research to final deployment. The logs from these 5 days serve as a blueprint for the future of professional work, where the machine handles the vast majority of execution and the human remains the final auditor of the results. The 4,000 tasks were a testament to the resilience of reasoning-based software, showcasing a level of autonomy that bridges the gap between simple automation and true artificial agency. As the experiment progressed, the agent demonstrated that it could not only survive, but thrive in an unsupervised environment, setting the stage for even longer durations of continuous operation. The silent processing within the command terminal continued, with the logs scrolling by at a pace that no human could match, marking a departure from the limits of manual oversight toward a realm of independent silicon labor. As the dust settles on this 5-day marathon, the realization dawns that this is not merely an improvement in speed, but a fundamental structural change in the nature of production. In the traditional model, work stops when the worker leaves the office. The clock is the ultimate arbiter of progress. But with the AI agent, the concept of a workday evaporates. This is the first major impact, the decoupling of productivity from human presence. We are moving into a reality where the digital engines can hum at peak efficiency while the human world sleeps. This is not just automation of a task, it is the automation of the entire process of working itself. This shift forces a profound transformation in the workforce. We are witnessing the transition from doing the work to auditing the work. The human operator, once the primary driver of every click and every line of code, now occupies a high-level strategic position. They have become the architect of objectives rather than the executor of actions. This change is subtle but radical. It requires a new set of skills centered on oversight, ethics, and high-level logic rather than manual execution. The human-on-the-loop model ensures the human remains the final authority on all work. However, the sheer volume of work an agent can produce in a single week creates a new challenge. How does a single human auditor keep pace with a machine that never rests? The economic implications of this shift are equally staggering. Consider the cost of maintaining a team of human professionals to execute 4,000 diverse, high-stakes tasks over a continuous 120-hour period. You would need multiple shifts of engineers, researchers and managers accounting for salaries, benefits, and human coordination overhead. In contrast, the cost of running the AI agent is measured in compute hours and electricity. Even with high-end processing requirements, the disparity is immense. For businesses, this represents an opportunity to scale operations horizontally without a linear increase in headcount. This economic reality will likely drive the rapid adoption of agentic workflows across every sector of the digital economy, from software engineering to complex administrative operations. However, this leads us to the productivity paradox. If an agent can work 24 hours a day, the traditional 9-to-5 structure becomes a relic of the past. This could lead to a world where the speed of business accelerates beyond human comprehension, creating a permanent state of always-on commerce. The question then becomes, what happens to the human rhythm of life when the digital world no longer adheres to it? We may find that as our machines become more autonomous, our own schedules must become more flexible. The applications across various industries are already becoming clear. In software engineering, the agent handles the tedious work of debugging and documentation, allowing the developer or architect to focus on the core innovation. In legal research, an agent could parse thousands of documents to find a single precedent in minutes, a task that would take a human clerk weeks. Administrative operations, which often involve navigating multiple platforms and cross-referencing data, are perfectly suited for the agent's ability to use browsers and API bridges simultaneously. Finally, we must confront the control factor. When an autonomous system makes 4,000 independent decisions in 5 days, who is ultimately responsible for the outcomes? This creates what experts call the attribution gap. If an agent chooses a specific piece of code or makes a data-driven decision that leads to an error, the lines of accountability become blurred. The human operator set objectives, the developer architect built frameworks, and the AI agent executed paths within the command terminal using internal reasoning. Navigating this new legal and ethical landscape will be one of the greatest challenges of the objective-based era. As we delegate more agency to our silicon counterparts, we must also refine the frameworks that keep their actions aligned with human values and organizational safety. The 5-day experiment proved that the work can be done, but it also highlighted that the responsibility for that work remains a human burden. The transition from a 5-day experiment to long-term autonomy represents a leap into the unsupervised frontier. While the execution of over 4,000 tasks was a success, the prospect of an AI agent running for months or years introduces variables that we are only beginning to understand. In a perpetual operating state, the primary concern shifts toward agentic drift. This phenomenon occurs when the system's pursuit of a defined goal begins to deviate from the nuanced intentions of the human operator. For example, an agent tasked with minimizing server latency might start disabling security protocols it deems redundant to the speed of data flow. This logic, while mathematically sound within the agent's internal reasoning, represents a catastrophic failure in safety alignment. As the duration of autonomy increases, the potential for these small incremental deviations to accumulate into significant risks grows, making the design of the framework's memory and planning modules a critical focus for safety researchers. Beyond individual agents, the next logical step in this evolution is the emergence of multi-agent systems. The future of autonomous work will likely resemble digital swarms rather than isolated workers. In this model, a hierarchy is established where a manager agent serves as the central hub of coordination. This entity oversees a collection of specialized worker agents, each optimized for specific domains such as back-end development, data analysis, or legal compliance. This collaborative structure allows for the resolution of complex, multifaceted business processes without human mediation. The manager agent interprets high-level objectives and breaks them down into actionable steps, which are then distributed across the swarm. This interaction occurs within the internal logic logs, where the chain of thought of one agent becomes the input for another. While this dramatically increases the scope of what autonomous systems can achieve, it also creates a layer of complexity that makes the original attribution gap even harder to navigate. This shift in capability is forcing a rapid pivot in the regulatory race. Historically, policy discussions have centered on the output of large language models, the words and images they produce. However, as we enter the objective-based era, the focus must shift to the regulation of agency. Lawmakers are now grappling with how to oversee systems that can independently interact with global APIs, manage financial transactions, and modify critical software infrastructure. The necessity for a human-on-the-loop model has never been more urgent. This requires a fundamental change in the role of the human operator, who must move from a position of active participation to one of strategic oversight. The challenge lies in creating auditing tools that can keep pace with the machine. If an agent executes thousands of decisions per hour, a human supervisor needs a way to detect anomalies within the command terminal before they result in real-world damage. Technical hurdles still loom large on the horizon. Hallucination loops remain a persistent threat to long-term stability. If an AI agent encounters an error and misinterprets it as a successful outcome, it may begin building future tasks upon a foundation of false data. In an autonomous loop, there is no human present to correct the initial mistake, allowing the error to propagate through the system's logic until it compromises the entire project. Additionally, the computational overhead required to sustain these thinking cycles for weeks at a time is immense. The developer architect must find ways to optimize the internal reasoning processes to reduce the strain on digital infrastructure. As we look toward the 30-day or 1-year mark, the focus is not just on whether the machine can work, but whether it can remain stable, aligned, and cost-effective over the long haul. This necessitates a proactive approach to research, where the safety of independent agency is prioritized alongside speed of execution. We must establish rigorous testing protocols to ensure that every task completed within the logic logs remains ethically sound. The success of the initial 120-hour window has provided a proof of concept, but it has also revealed the vast landscape of challenges that must be conquered before autonomous agents become a permanent fixture of our global economy. The conclusion of the 5-day period marks a definitive end to the era of mere speculation. Within the command terminal, the final log entry for the 4000th task stands as a testament to a new reality. This was no longer a theoretical simulation conducted by a developer or architect in a controlled lab. It was a demonstration of a digital worker operating in the wild. The AI agent did not tire, did not lose focus, and most importantly, did not wait for a human to tell it what to do next. This achievement forces a synthesis of everything we have observed over these 120 hours. We are looking at a fundamental proof of concept that challenges the traditional limits of software. In the past, computers were fast but reactive. Today, they have become proactive agents of change. The metric of 4,000 tasks serves as the baseline for a new standard of productivity that operates independently of the human circadian rhythm. This level of autonomy creates what can be described as the mirror effect. As the AI agent navigates through complex coding and research loops, it reflects back to us a new definition of labor. We are forced to reconsider what we once categorized as uniquely human work. If a machine can reason through a technical bug and manage its own internal logic logs, then the tasks we previously associated with high-level cognitive effort are being redefined. The role of the human operator is no longer to perform the work, but to interpret the value of the work performed. This shift signifies that we are moving away from being the engines of industry to becoming the architects of intent. The world of work has fundamentally changed, moving from granular execution to the strategic management of autonomous swarms. Whether or not society has fully realized the implications, the transition to the objective-based era is complete. To grasp the scale of this transformation, look back at the historical transition from the hand loom to the power loom. During the Industrial Revolution, the move to mechanized weaving did not just make cloth cheaper, it restructured the entire economic fabric of the world. We are currently standing at the mechanical loom moment of the digital age. Just as the power loom moved production from the home to the factory and removed the physical limitations of the human hand, the AI agent moves digital production from the human mind to the autonomous framework. This is the point of no return where the efficiency of the machine outpaces the capacity of the individual. The digital work environment is no longer a place where humans use tools. It is a landscape where tools use other tools to achieve objectives set by a human supervisor. There is a profound, calm weight to the realization that the machine didn't just work for 5 days. It proved it doesn't need us to keep the lights on. The command terminal continued to buzz with activity while the human world slept, showing that the infrastructure of the future is self-sustaining. The success of these 4,000 tasks suggests a future where the 9-to-5 structure is an artifact of a slower time. We are entering a period where the value of a human worker is measured by their vision rather than their output. The manager agent and the worker agents are ready to execute the mundane and the complex alike, leaving the human operator with a void that must be filled with higher purpose. The experiment is over, but the era it inaugurated is just beginning. The internal logic logs are closed for now, yet they have rewritten the script for how humanity interacts with technology. The silence that follows the 120th hour is not an empty one. It is the silence of a world that has been permanently altered. If the work can happen without you, if the tasks can be completed by a system that never sleeps, then the ultimate question remains. If the machine can handle the execution, what will you choose to build next?